Hello everyone, welcome to this session. Our chapter is waves. So far in our previous session, we discussed about the propagation of these waves. We discussed the electromagnetic waves and the mechanical waves. So today, let's move on to the other part to discuss about the sound waves. In sound waves, we specifically see echo and reverberation. We start with the concept of echo and reverberation. Uh, let's start with echo. What's echo? An echo, this simply occurs when the sound wave is reflected and then it arrives to the listener just after some time delay after the direct sound. So, just echo, you can then say is a reflected sound. So, so it's just that kind of reflected sound that is a sound that arrives later on with some kind of a time delay after the direct sound. When we are, take an example, when we are in an empty space surrounded by, for example, mountains, and we shout loudly, we will notice that we see that faint sound resembling the original sound coming back just after some delay of time. Now, that kind of coming back of that resemblance of the original sound is what we call the echo. So this perception of the reflected wave is nothing but the echo. Now, this is experienced also in remote places, in rooms that are big and empty, and in caves, buildings, and also in these big forests. So there is where you can experience this kind of sound effect known as echo. So echo, this word is just derived from the Greek word, which simply it means sound, and therefore is a reflected sound. Now, the echo is just produced due to hitting of the sound waves with the obstacles, which makes the sound just to reflect back. So that's the mechanism of what happens when an echo occurs. Yes, the original sounds when hits the obstacle, meaning that the sound just goes back or just reflecting back. Now, let's see the application of echo. The first one is that echo can be used in measuring distance. By knowing the speed of sound and measuring the time it takes just to hear the echo, you can then calculate the distance of the object. Now, for example, a sonar device, the one that displays this kind of mechanism, it sends out a sound, and automatically it calculates the distance of an object. Uh, some marines also, they use the sonar just to find objects under the water, including the other submarines. So this application of echo, that is calculating or measuring the distance shown by the sonar equipment, can be used by these submarines just to look for other submarines under the water. The ping sound that you heard in a submarine, it just comes from the sonar device sending out the sound wave under the water. Now, fishermen also use the sonar just to find the schools of fish. What they do is that since this is an electronic device, the sonar equipment, the time it takes for the wave just to return can be much less than 0.1 second required to hear an echo. In such a way, for example, if the speed of sound in water is maybe 1,500 meters per second, and the fisherman's sonar device, it detects an echo in 0.02 seconds, the distance of the object underwater will be calculated as follows: d equals to v times t, whereby equals to 1,500 times 0.02 seconds, you get 30 meter. That is just the distance of back and forth movement, and therefore that may mean that a school of fish is just about 15 meters away. So that's how the echo can be used by the sonar equipment for these fishermen just to detect or to know the school of fish where they are located. Also, the sonar and radar work are also on the same principle. In a way that sonar, it uses the sound waves, while the radar, it uses the electromagnetic waves. So here you can get the difference, but all they use the concept of this reflection of sound, that is the echo. Uh, the other application of echo, velocity, can calculate the velocity by the echo. When a wave bounces off a moving object, the frequency of the sound, it changes according to the relative velocity of the object. Now, therefore, we can get the velocity, and whereby velocity is just the measurement of speed and direction. So if the object is moving toward you, the frequency or the pitch of the sound, it gets higher, and when it moves away from you, the pitch gets lower. Now, the faster the object is moving, then you can tell the greater the change in frequency or the pitch. Now, this is what we call the Doppler effect. So you can see here, the Doppler effect is one of the clear application of how echo can be used. How it works is that, for example, you've probably expressed the Doppler effect when you heard how the sound of ambulance siren, it changes pitch as it passes by. You notice that when it passes by, there's kind of a change of the pitch of the ambulance sound. Now, the Doppler effect, it can be used to measure the velocity of an object by comparing the frequency of the sound sent out to the frequency of the sound reflected by in the echo. So the sonar device is also usually used to calculate the velocity of the object. Note that you have to know that the Doppler radar works on a similar principle to measure the speed of storms in weather prediction, except that it just uses echoes from these electromagnetic waves. The other application, uh, echo can be used by these birds just to find the moth. Birds use the echoes just to find the good tasting moth while flying around at night. You may notice that the birds, they send a sharp creak or chirping sound, and then it hears and processes any echoes of other objects in the area. So in that way, they can detect or they can find the moth. So, but these birds, they have these large ears that are very sensitive to sounds in certain wavelength, and that's how they can use the echo. Moving on, let's finish up discussing about the reverberation. We've covered the echo, the meaning, and the various application of echo. So let's see what is reverberation. Reverberations, these are just the collection of reflected sounds from the surfaces in an enclosure. Take an example like an auditorium. So this is just a collection of these various reflected sounds. It is the desirable property of the auditoriums just to extend that it helps to overcome the inverse square law drop off of sound intensity in the enclosure. So that's why the reverberation is very critically needed in these places, the auditoriums or any enclosures. However, if this reverberation happens to be in excessive, it makes the sound run together with the loss of articulation, whereby the sound becomes muddy or garbled. Now, that's why it has to be maintained in balance. Here's how it looks like for the reverberation, how it takes place. For example, in a place of enclosure that is the auditorium, you might see here is the source of the sound, and you can see the various reflected sounds just head to this individual who is sitting right over here. So that's how reverberation works. So reverberation is just the same as echo, but the distance here is less. So in the reverberation, the distance of traveling of the sound is less than compared to that of echo. The distance between the source of the sound and the obstacle by which it is reflected is less in the reverberation. So that has to be clearly noted. Uh, Here in reverberation, the time delay is just less than 0.1 second, and the reflection, the reflected wave, it reaches the observer in just less than 0.1 second. So now, as the delay in time is less than in the original sound, is still in memory, so the delay between the perception of the sound and the original sound is very, very less. So that's how you can tell the difference between the reverberation and the echo. So I hope that's clear, everyone. Thank you for listening. We've discussed about the echo and the reverberation. We've dived more into echo. We've seen the meaning of echo and the various application of the echo, and then we've seen what is the reverberation, which is just the collection of the reflected sounds or collection of echoes. So I hope that's clear, and thank you.